All right, guys. Good afternoon and welcome back to class. And now, without any further ado, today we'll be talking about regressions. Let's see how to perform regression analysis, right? So, what actually is regression analysis? It is kind of like it evaluates the relationship between one dependent variable and then with one or more independent variable, right? So it helps to determine the strength of this estimated relationship and then defines the future relationship between the variables, right? Okay, so this can then we can then numerically assess how the fluctuations in the independent variable affect the dependent variables. All right, so without further ado, let's make a practical example. So we have income and then we have the saving, these two columns down. So for someone that earns, he earns 1,000 as income, how much does he save? He saves 450, all right? So for 2,100, he saved 850, and all this information is given, right? So now, what we have here is that the income here is what we call the independent variable, and then we have saving here to be the dependent variable, because you have to understand, you have to know how much income you have in order for you to know how much you're going to save. So saving is dependent on the income. So how are we going to perform a regression analysis on this, right? So we are going to be doing what we call a linear regression, right? So we are going to be looking at the relationship between these two columns, between income and saving. That's one. Looking at the relationship, how close, right? So what's the level of proximity between them? Are they really, really together, right? So we're also going to be looking at how we can predict. So linear regression can be used to predict, okay? So if you can tell for 2,500, it's going to be saving 1,000. How about 3,000? How much would you be saving? How about 4,000? How about 5,000? So that's the essence of linear regression, right? So without further ado, let's just jump straight to business. All right, the last time we talked about the Data Analysis Toolpak, and then it's a whole lot of a package that can allow for us to do some very cool stuff, some cool analysis. I'm going to bring down my Data Analysis Toolpak, and then I'm going to be searching for my regression. All right, so I'm going to be looking for regression, and that's it. I selected, and that's it. Now, so we have sorry, I'm going to erase that so that we can look at that again. Erase this. Right, so we can look at that again. All right, so we have the input range, right? So remember that the input range, the Y there stands for the independent variable, right? So the independent variable in that case is a saving, right? So yes, sorry, Y is actually the dependent variable, right? So the dependent variable in that case is the saving. Yeah, it depends on the income. So we're going to take that. Notice that I'm taking that from here. And then we have the independent variable, which is income. I select this and I drag my income from here down. Note that I did not select this 3,000, okay? But that's what we're trying to predict. We're going to be predicting that. So I'm going to select my labels on because I'm taking them. If you fail to select the labels, it's going to give you an error. And then how about our output range? We want our output range to be here. We don't want it to be on the new sheet so that we can compare them. And then so I'm going to select my output range, select this. I want my data to be from here. Okay, let's make it from here. Right, so, and then, all right, I don't want all these residual standards, but I might get to choose the line fit plot so that we can see how that works. And select this, let's make it real simple, and that real quick, and there we okay. And now, like so, immediately our information pops for us, and we can tell everything we need to know. I'm going to remove some of this so that we can really have a view. Okay, delete. Okay, all right, so we have this now. We have a summary output. We have a summary output. Now there are a couple of things there. These are all statistical terminologies, which we may not really get to talk about, but there's some I need to explain. So we have the summary input of the regression analysis we just did. And let's just summarize, let's just talk about what these things do and what they actually mean. So the first one here is a multiple R, where we have regression statistics, we have multiple R. What does that really mean? It denotes correlation, the correlation coefficient, right? So an absolute is an absolute value that determines how strong the linear relationship is between the two variables, how strong the linear relationship is between the income and the savings. Now it's always between -1 and then and +1, right? So it's always between that range. Now, as we can see here, for a multiple R, we have 0.9, and that's a very strong positive coefficient. So it means that the correlation coefficient is very, very strong. That's 0.9. So we can tell that income to saving is very, very strong. All right, then we have the R square. Yeah, the R square is a coefficient of determination. It gives a summation of all the squared deviations of the data points from the mean. So we should have something like 0.95. 0.95 is excellent, but in our case, we have 0.97. That is very, very good. So we can tell that our correlation is actually on point. Okay, and there are other ones that excuse me. We have the adjusted R square. Right, so the adjusted R square simply means is a value that is considered. Is the adjustment made, all right, to the R squared value, considering the independent variable count, right? It's just a slight adjustment that is made here. You can tell that they're almost the same, 0.9756, and you can tell the difference. Then we have the standard error, that's for the 3, and then it shows whether the regression analysis and the corresponding equations are precise, right? And then also we have the observation. So number of observations we have is 10. So you can count all observations or data points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the observation is 10. All right, so that's what we call regression statistics. And then we have the ANOVA analysis of variance. All right, we may not really talk about that, but the real thing we are looking for, or we're looking at, is what we call the intercept and the income, the coefficient. Remember that the income is actually the independent variable. All right, so we have the coefficient of both of them here, and then we're going to talk about that. We have coefficient, standard error, we have t-stat, p-value. These are all statistical terms which I may not really go deep into, like trying to like explain about that. But the key thing here is that we are trying to like make predictions, right? So we're trying to like make predictions based on what? Based on this. So what are we actually going to be using to make our prediction? We're going to be using our intercept here. So the intercept here, the prediction model is given like this: y is equal to a plus bx. All right. So now we have y is what you're trying to like to get out, right? What you're trying to like get. Let's say the value, how much saving you are going to be making. How much are you going to be saving if you're earning 3,000? So that's what they're trying to achieve. So the whole of this right side of the equation, a plus bx here, should give you the value for what? For 3,000. Okay, so for 2,500, we had 1,000. How about for 3,000? So that's what y actually represents. Okay, and then we have a there is simply this coefficient, the intercept. So we have that to be the intercept, and then we have b, and we have b is the coefficient, right? B is the coefficient, which is the income, the coefficient of income, and then we have x. X is going to be the 3,000 here, which we're going to be plotting into the equation. So let's do that real quick, and then let's do that real quick and see how that's going to work for us. So we say equals to, looking at this formula, so we have a. So what is our a? We move down here immediately and say, okay, our a is the intercept, and we select that. Okay, select that. A plus bx, right? So what is our b in this situation, right? In this instance here, our b is actually the income, right? So we select this. Okay, b. Select this. Doesn't matter which one comes first. That multiplied by what? The x is actually this 3,000 here. So select this 3,000, like so. Okay, and having that information, voila, we can tell that for an income of 3,000, you'll be expected to save 1,217. That's quite cool, right? All right, so how about if we drag it down? Let me look for 5,000. We search for 5,000. How much are we expected to save? All right, so remember, I want to show you something. I just try like jog the memory. If I drag this one down here, it's going to be giving me a very wrong result. Why? Let me show you why real quick. Reasons, because this is supposed to be, remember, absolute reference. I'm going to absolutely reference this like this. By now, you know what absolute reference does like this. So I anchor those two cells so I can drag the values down here that we can tell. Oh, I beg your pardon. That's not the one I was supposed to. Oh, sorry. Get data out of this. You know the one I'm supposed to anchor. Rather, this is the guy. Okay, and I'm dragging it down. So we can tell that for 5,000, you actually is going to be saving 2,073. All right, or let's make it for let's say 10,000. How much am I going to be saving? I drag this one down like so. You can see I'm going to be saving like 4,212. So you can see the relationship between the income and the saving. All right, for every income given, I should be able to predict how much I should be saving. So this is where linear regression comes into play, and we observe how we use the data analysis toolpak to make that real quick, and all the summary statistics is given for us to see the regression statistics, not summary statistics. I beg your pardon. We have all DF, SS, and all those terms like. I may not be able to explain all of that at the moment, but that's something we should know. All right, so that's just a simple way of making predictions based on and the columns that you've been given. And then this one gives you the regression, the linear regression chart. So you can tell that the model is actually a straight line model. It's kind of like, as you can see, the model is linear, right? So we can see the saving and then the predicted saving. So you can see the saving and also the predicted saving. You can see it has linear equation like this, saving by income. All right, so that's the side of the class in this. I don't want to make this video very long. This is a simple linear regression project we just did. So we're trying to like tell relationship first, relationship between the income and saving. And then we observe that relationship is very strong. Why? Because the correlation coefficient is quite strong. That's almost 1. That's one thing we saw, and then we also we were able to observe, and then we made predictions based on the income, right? So what our model did was that it trained the income and then the savings, and then with that we were able to get the coefficient and then the intercept, which we inserted into our formula to see how to like predict the income for income for when it is 3,000, when it is 5,000, when it is 10,000, all that information. So that's the class today. All right, so have a wonderful time. See you when I see you.